Climate change is making it clear what a precious treasure we have in water.
We simply want to use the groundwater we have, good safe water, as efficiently as we can.
Yet too much water can become a threat too. We face a great two-part challenge, managing weather extremes while protecting our planet's vital water resources. Construction on Hamburg's sewer system began over 180 years ago. The old masonry is still in place. Public Works Supervisor Dirk Grünert inspects it regularly.
Here, look. That's pretty deep. 3 centimeters.
Pretty significant.
These walls are easily repaired. What's of greater concern for the man responsible for their maintenance? Increasingly extreme weather. No sewer system was designed for that, not even newly built ones.
During a downpour, we wouldn't be able to stand here. The water would be up to the ceiling. We tried to avoid overflow and aim to use all storage resources to their fullest. But you simply can't scale up a sewer network to handle the kind of rainfall we're seeing nowadays. It's simply not possible.
When the sewer system fills up, water from the streets can no longer drain through the gutters, leading to flooded streets. Since so many surfaces in the city have been covered by asphalt and concrete, rainwater can't seep into the ground. But heavy rain isn't the city's only problem. Heat and drought can also pose a threat. Hydrologist Andreas Kuchenbecker wants to make Hamburg more resilient for both weather and water.
We can only protect ourselves from dangers if we know how great they'll be. If we don't measure, it's all just guesswork.
That's why Kuchenbecker has set up 30 weather stations to send him data from across the city. This precipitation gauge shows how much rain has fallen.
It's basically a collection container to capture rainfall and measure it on a very sensitive scale. We can see in real time how much precipitation is falling at this location.
The hydrologist uses this data to model the likelihood of various scenarios.
We have to look at what would happen if we experienced a heavy rainfall event of intensity level 8 or 10. It's best not to wait until we actually do have an event like that, but rather to feed that kind of information into our models and see what the outcomes of such extreme rainfall would be.
His weather data helps the municipal water supplier adapt its urban planning. Andreas Kuchenbecker and colleague Andreas Bayer have created a model of Hamburg using simulation software. They can now make a forecast for every single address in Hamburg.
Okay, so we see a massive overflow of water here. That's obvious.
We have the advantage that this park is directly adjacent. We just need to divert the water away from the properties and the street into the park. That's likely to reduce the risk of flooding.
So lower things a bit here and raise them a little here.
Using the simulation, the two test different solutions. Could a ditch help channel rainwater into the park?
We don't need to lower it too much. That's not necessary.
Try 10 centimeters for now.
Okay, sounds good.
Erecting a small dam on the other side of the street could help protect the houses. They drop the structure into the model, and the software immediately calculates how it would affect the flow of rainwater.
Let's see if your elevation actually made a difference.
Okay, looks like the water only goes up to the edge and the rest flows toward the park, as intended. Very nice.
The soil in the park can absorb the redirected water, one of many ways officials are turning Hamburg into a so-called sponge city. Along with absorption areas and parks, plans call for measures like green roofs, permeable pavements, and rainwater reservoirs. Water remains where it fell, nourishing plants during heat waves and helping to keep temperatures down. All these efforts aim to make Hamburg more climate resilient.
The city's transformation into a sponge city has two advantages. On the one hand, we're reducing the strain during heavy rain. On the other hand, we're lessening the impact during long dry spells. It's basically a win-win situation, protecting both our drainage and drinking water supply systems.
Hamburg schools are setting a good example. At this high school, the grounds were redesigned based on Kuchenbecker's simulations. Environmental engineer Bo Willem Friedrichsen oversees many such improvement projects, aimed at turning the city into a sponge with many small holes that soak up water.
Almost all roof surfaces now drain into retention basins. That has several advantages. It promotes a more natural water balance, helps restore groundwater, and evaporation from these basins helps cool the city's climate.
So that was 7.2 metres and 9.9 metres, 19 cubic metres. It's amazing how much a basin like this can hold. That's really the best part. You develop a model with lots of measurements and simulations and then see it implemented here on a school campus. That's incredibly motivating.
It's not just the basins that absorb water. Water-permeable areas in the schoolyard also help rainwater get into the soil. One example can be found behind the school.
On the sports fields, large asphalt surfaces were removed and replaced with water-permeable ones. These allow rainwater to make its way into the groundwater. The water runs off at first, but then it's absorbed by the surface and seeps into the ground.
The rain seeps in and keeps the soil moist, rather than flowing into the sewer system.
Most important of all is that we start, that we simply begin and gather experience step by step. New generations will learn from these experiences and maybe do it even better than we do. But someone has to start.
He's not alone in his pioneering spirit. He has a colleague with an idea that could help prepare Hamburg for future heat waves. Tunisia is used to scorching heat, but climate change is making drought even worse.
The subsurface soil, it is dry. Look, it is dry. Look, dry, nothing.
Entire plantations in Tunisia are now under threat. Bellachheb Chahbani could have retired long ago, but the agricultural scientist wants to help local farmers. For centuries, they used a clever trick to make agriculture possible in the desert. They erected stone dams to trap rainfall. Whenever it rained, water collected behind the structures and seeped into the ground. That kept the soil moist enough for plants to grow.
This old system, it's not more sustainable. Why? Because of climate change. Because the rain is not very often. It comes maybe every 7-8 years, good rain.
Hardly anything grows without irrigation, and most of that water evaporates.
There is a possibility. Instead that the water remains above the soil, it should be injected below the soil.
For many years, Bellachheb Chahbani was a university professor and researcher. He invented an irrigation technique designed to work with much less water. Chahbani is lending a hand in Tatooine in the south. The olive trees on this plantation are watered with groundwater, a resource that's growing scarce as the water table keeps dropping. Using his irrigation technique, the agricultural scientist aims to reduce the farm's water consumption by 2/3.
So this is what we call buried diffuser. This is the diffusing part. You see, here there is gravel, silicium gravel. Then all this part is buried. So like that, the water is delivered 50 centimeters below the soil, no evaporation at all.
This way, farmers use 70% less water. 4 water diffusers are buried around each tree. They're placed close to the tree's roots. Each of them connects to a water pipe that brings groundwater to the diffusers, like an underground watering can. To ensure that people have enough drinking water, agriculture has to save water. In Tunisia, it's still consuming around 80% of the precious resource. That causes problems.
In the north, most of the water comes from the dams. If there is no water in the dams, Tunis city, 1 million inhabitants, they have now water shortage.
It's why Chahbani wants to protect the country's supply. These 300 olive trees will be irrigated using his water-retaining method. Yet many farmers remain skeptical. Dr. Chahbani needs to do the hard work of persuasion.
Here, about 20 days ago, we installed a buried diffuser. You see here is the buried diffuser, 50 centimeters below the soil. We connect it to the big tank, 1,000 liters. Now we will see where exactly the water is spread underground. تبدأ بهكة ومن بعد البارتي الأخرى 3 متر هنا و3 متر منا. Okay.
The expert has invited farmers from neighbouring farms to observe how the system works. They're to see with their own eyes how the soil around the diffusers stays moist.
العروق حسين بكري قال لي ولا عروق ما هم من فوق. العروق تو يتبعوا الماء بعد. يا بطلوطة يعني عروق جدد ايوه. لافونتاج لي بيرت بار ايفابوراسيون ما عادش تسقي ديما تولي مرة في الترميستا.
And indeed, the soil around the water diffuser is soaked.
We have a humidity bulb of about 3 meter diameter, 4 meter depth. Imagine each tree has 4 areas around with such humidity. So it has enough soil to expand the roots, and when you have more roots, you have more production. I am happy when more and more users do it. The beginning is hard, but later, slowly it will be spread.
The fight for water is also a fight for the farmer's only source of income. In Hamburg, 17 waterworks supply the city with groundwater. During summer heat waves, water consumption skyrockets, a challenge for the facilities. Engineer Dorothea Mergel wants to conserve water and prepare the city for dry periods. At the Neugraben Waterworks, she meets plant manager Alexander Kapitän.
So, the filter.
Currently at 100.
Let's see if everything's working.
Here, groundwater is processed and turned into drinking water. But even cleaning the filters requires clean drinking water, water lost from the public supply.
We face challenges such as climate change and also the fact that Hamburg is growing. More and more people are moving here, increasing demand for water.
Groundwater contains iron and manganese. To remove them, the water seeps through filter basins filled with sand and gravel.
Let's start the backwash. Yeah, hi, Alex here. Peter, could you rinse filter 3? Thanks, bye.
The sand filters are regularly cleaned and flushed with drinking water. That water then becomes wastewater right here at the waterworks. Dorothea Mergel has come up with a way to retain that water in the future.
We simply want to use the groundwater we have, good safe water, as efficiently as we can.
Up to 4% of drinking water is lost during filter rinsing, water that could be turned back into clean drinking water quickly on site. Currently, it's quickly filtered and discharged. Most of it flows into the sea, where it has to evaporate and rain down again before it can be processed into drinking water once more.
Hi, how's the system running?
Running pretty well so far.
Along with Charlotte Kast from Hamburg's Technical University, she's researching a special water filter, one designed to remove iron and manganese particles from dirty water.
There's a ceramic filter inside the filtration tank with tiny pores that trap solid particles. The treated water flows into this container, and you can see it's much clearer than before.
The water may look clean, but does it also meet the high-quality standards for drinking water? Dorothea Mergel is testing that in the lab. If her filter works, it could save over 4 million litres per day in Hamburg alone, water that could quickly be made available again as drinking water. That's the daily water demand of more than 30,000 people.
Hi, Joscha. I brought 2 samples with me.
Okay, thank you.
One is grey water and one is filtrate.
Okay.
Got it, thanks.
Joscha Tetzlaff compares the dirty and cleaned water. If the filter works, Mergel wants to share the technology with other water treatment plants.
We're now measuring water cloudiness. We'll just put it in here briefly and end up with a reading of 0.09 FNU.
Yes, that's an excellent number. Very low. The limit for drinking water is 1 FNU.
But better safe than sorry. Joscha Tetzlaff double-checks his findings with a mass spectrometer to see whether the filter really has removed the metals completely.
Your outflow contains 0.35 milligrams of manganese and iron below the detection limit. It looks very clean.
The result proves that the water treatment is working. The membrane is functioning very well.
Mergel's research is an important contribution to safeguarding the water supply across all of Germany.
It would be a big win for the entire project, and me personally, if the technology was eventually implemented in many waterworks. Rinse water is recycled in many plants, and that water would be made available for the drinking water supply.
Every drop counts. It's why officials at the Hamburg waterworks are also testing ideas for how the city can save even more water. A farm in Widref, Tunisia has recently begun using Dr. Chahbani's irrigation system on a large scale. These 4,000 olive trees are growing in a region that has suffered severe drought for years.
سي شعباني مرحبا بك.
اهلا سي الحارس. يا مرحبا.
يا ودي مرحبا مرحبا.
يعطيك الصحة.
لحالك لاباس.
These trees are a year old and have already survived one summer of drought.
شفت هذا الجريان بتاع العيون هنا. شفت هذا كله جديد هذا كله جديد هذا تاع النان وهذا أخضر وهذه
Suhail Osmain now lives in France but returns to his homeland as often as he can. He's taken over his grandfather's farm. Just 50 years ago, his grandfather grew grain here. Now, the area is covered in dry sand.
L'eau était existante.
There was water. We had the quantities we needed to grow wheat. There was rain and plenty of groundwater. But today, with global warming, there's no more water. Water is very scarce.
Chahbani's invention could mean salvation.
We discussed to have an experiment and we will try the buried diffuser to produce wheat next season.
The farm lies only 8 kilometers from the sea. The groundwater level has fallen so much that salty seawater is seeping in, making the supply unusable for agriculture. Osmain had to buy a desalination plant, which consumes a lot of electricity. The investment is worthwhile only because water consumption is very low, thanks to the underground water diffusers.
Dans notre cas, on utilise, retenez-vous bien,
We use, hold on to your hat, only 2 cubic meters of water per hour for 4,000 olive trees. I don't know if you can even imagine that ratio, all thanks to the water diffuser.
grâce au diffuseur d'eau enterrée.
Each sapling needs about 4 litres a day. Altogether, his plant removes about 22 kilograms of salt from the water every day. Officials have granted Osmane a permit to deposit the mineral in a natural salt lake, a process that does not harm the environment. The government is subsidizing these irrigation experiments because they serve as pilot projects. The two men are proving that agriculture can still function in regions severely affected by climate change.
The buried diffuser is like one of my kids. If I arrive that the buried diffuser is used at a large scale, and this is a large scale, 30 hectares, with good results, so I reach my goal.
The system invented by Chahbani, now over 70, could also be useful in southern Europe, an area increasingly suffering under summer temperatures of more than 40 degrees centigrade and extreme droughts. In most of the world, agriculture is the biggest consumer of water. In Europe, it's industry. The Carlsberg brewery in Fredericia, Denmark, churns out several million cans and bottles of beer every day. Andreas Kierketerp is leading an ambitious project aimed at reducing the plant's immense water consumption.
So, here at Carlsberg we use about 2,000 cubic meters of water for process only. This water will go to the drain, and on other breweries it would go to the municipal or to a wastewater treatment plant in the area.
Large amounts of water are used for cleaning and pasteurization.
A machine like this will use more or less the same amount of water in one day as a household of 2 will do in a year.
The engineer owes his job to that mind-boggling fact. The Carlsberg Group created his position, that of chief water recycler, because it wanted to conserve resources. It built an entirely new facility, one that reprocesses water directly on site. By no longer discharging water into the public sewer system, but cleaning it here, the brewer has created a closed water cycle.
This plant will create around 500,000 cubic meters of water every year. It means a lot that we clean this water. It is 500 million liters of water that we don't take from the city supply. Yeah, I think it's important. I have 2 children, and I also want them to be able to drink water from the tap in the cities. So this is a big motivation for me.
The system recycles a full 90% of the plant's wastewater. In just 2 years, it conserved 1 billion liters of water.
This one is the oxygen measurement that you use to monitor how much oxygen is in the aerobic process. And it needs to be in a certain level to have a stable process.
The dirty water is repurposed. It's used in the brewery's biogas plant.
That is 10 to 15% of our total heat consumption of the whole factory.
The in-house treatment plant is a pilot project. Carlsberg operates over 80 breweries worldwide, 16 of them in particularly hot and dry countries like India, where saving water is an even more urgent matter than in Europe. Ensuring a stable water supply for people is crucial, and industry can play a significant role in achieving that goal. Just how well the purification process works is obvious.
Here we have the wastewater we started with, and here we have the pure water, as we call it in Carlsberg, so water with drinking water quality.
It's then reused in production for rinsing and pasteurizing, thereby creating a full water cycle.
I hope this will be something that will pop up in many industries and not only within the brewery industry. The water in the world is a scarce resource, so we should do something about it, and this is one of the solutions.
Because of its water recycling system, the Fredericia plant has been recognized as the most water-efficient brewery in the world. Conserving and preserving water. Climate change demands great ideas and pioneers who put them into practice. At home and in communities, in agriculture and industry, our water is far too precious to waste.
Wie sieht's aus in Hamburg? Ist das Wetter noch intensiv?